Okay, today we are doing a critical deep dive. We're looking at something that's really shot up the agenda, moving way beyond theory into, well, the strategic boardroom. We're talking about governing AI and closing that accountability gap.
Hmm.
AI is just accelerating everywhere, right? These complex systems are getting embedded in really critical functions, sometimes without anyone really noticing.
Right. And that speed, that integration, it presents this huge challenge strategically, legally. For you, the listener, it boils down to this. When an AI messes up, maybe financially, ethically, could be discrimination, who exactly is on the hook?
That is the question. And the sources you've pulled together, they
Mhm.
show we're moving past that initial kind of Wild West phase of just building AI models as fast as possible.
Exactly. We're shifting to the absolute necessity of, rigorously governing them, putting guardrails in place.
Absolutely. So our mission today is really to unpack all this. We want to move beyond just talking about AI ethics in the abstract.
Yeah, get practical.
Exactly. Extract the practical blueprint for managing these risks. We're aiming for the applied competency guide for responsible AI.
And what's really fascinating, I think, is how the sources frame this. They call it a socio-technical challenge,
Socio-technical.
meaning you can't just solve it with tech tools.
Okay.
And you also can't solve it just by writing down policies. You need this holistic strategy built on three pillars, all working together.
Okay, let's lay those out. So pillar one is people.
Mm-hmm.
Developing an organizational culture that really gets responsible AI curation, making sure everyone, top to bottom, understands the stakes.
Then pillar two,
Mm.
processes. This is about defining, documenting, implementing really clear AI governance procedures, mapping out that whole AI lifecycle.
Right.
And third, tools. Using the right AI engineering frameworks, the right technical controls to actually manage the risk you've identified. You really need all three. If one's weak, the whole thing's unstable.
I wonder, though, do organizations sometimes focus too much on the tools, the shiny tech, and maybe neglect the harder work on people and processes?
That neglect is precisely the issue. It's why the sources pinpoint the central problem, the accountability gap, sometimes called the Verantwortlichkeitslücke.
Right, the German term.
Yeah, it just means that gap where organizations use AI, but nobody has clear ownership for the outcomes. Surveys from AI summits, they keep highlighting three really problematic answers leaders give when asked about accountability. They're like flashing red lights for governance failure.
Okay, what's the first one? The worst one?
Oobity.
Oof.
Yeah, that's alarming.
It signifies a total vacuum of governance. It means the whole organization, board, legal, ops, they're all exposed to massive unmanaged risk. Flying blind, essentially.
Okay, answer number two sounds like denial. We don't use AI.
And, well, that's almost always false, especially in bigger companies. Maybe they haven't deployed some huge custom system, sure, but individuals, employees, they're definitely using non-inventoried AI tools. Cloud stuff, generative AI, shadow IT.
Stuff that bypasses all the formal checks.
Exactly. Introducing huge data risks, IP risks, completely outside of any oversight.
And the third answer, everybody. That sounds collaborative, maybe. Collective responsibility.
It sounds good, yeah. But the reality is different. When responsibility is spread across everyone, effectively no single person or group feels specifically accountable for a specific outcome.
Right, if something goes wrong.
Finger pointing starts. Data science blames data collection. They blame the business unit. You get inaction. Accountability needs definition. Everybody defines nothing concrete.
So it's crystal clear. Closing this accountability gap, it's mandatory. It's not a nice to have for a sustainable AI strategy. And the only way to close it is with a clear structure, which brings us to the responsible AI leader.
Yes, and this isn't just some informal ethics committee meeting now and then. It has to be a dedicated leader, maybe a team, with a clear, specific, and crucially, a financed mandate.
Financed, yeah. Resources matter.
Immensely. If it's just an advisory role or underfunded, governance gets neglected. The risk just sits there, festering.
So let's break down their mandate. The sources show it's getting bigger all the time. First up, value alignment.
Right. Making sure the AI systems actually reflect and reinforce the company's own values, ethical and commercial.
Then there's the hard technical part, managing the inventory issue.
The inventory, yeah. Meticulous inventory and continuous monitoring of all AI models. And critically, including those shadow IT tools employees are using, you need that visibility.
Okay. And they also need to be plugged into the wider world, right? Tracking AI regulation globally, which is exploding.
Absolutely. And it's often conflicting between regions. But it's not just about ticking compliance boxes. It leads into ethics management. Going beyond just what's legal to tackle that tricky gray area, situations where an AI model might be, quote, lawful but awful.
Lawful but awful. That phrase really hits it, doesn't it?
It really does. It captures the core challenge. A system might follow all the current laws, data protection, non-discrimination, which are often lagging behind the tech, but still produce results that are socially damaging, wreck the company's reputation, or just destroy customer trust.
Like a chatbot giving technically correct but morally dubious advice.
Exactly. Or a pricing algorithm that squeezes every last cent of short-term profit but alienates customers long-term. The responsible AI leader has to navigate that very nuanced ethical space, protecting the organization's long-term value.
So to handle all this compliance, inventory, ethics, this leader needs real clout, strategic placement, a seat at the table, as they say.
Definitely. Involved in C-level strategy, collaborating closely with other key players like the CISO, the Chief Risk Officer.
And integration is key, you mentioned.
Absolutely critical. AI ethics and risk management have to be woven into the entire life cycle, from the very first idea through development, testing, deployment, monitoring. It can't be an afterthought, like some audit tacked on at the end.
And the policies that come out of this, the accountability policies, they need to be transparent.
Organization-wide transparency, so everyone knows the rules of the road.
Which brings us back to the people pillar again. The teaching mandate. The leader needs to be a damn good teacher.
Ah, yes. Their job isn't just writing rules down. It's about continuous training. Developers, managers, people buying AI tools, domain experts, getting their daily work aligned with the company's values and governance standards.
And that training, the applied AI literacy or Schulung, needs to be practical, right? Tailored.
Super practical, highly targeted. Different roles need different things. So the governance teams, the governing group, their training focuses on operationalizing principles, fairness, explainability, transparency. How do you actually do that?
What does operationalizing look like in practice for them?
It means defining not just the functional requirements, what the model does mathematically, but also the critical non-functional requirements.
Like system uptime, audit trails.
Yeah, exactly. Reporting thresholds. And, crucially, the systems and processes around the model that ensure its use safely. For instance, if the model flags a high risk, a non-functional requirement might mandate human review before any action is taken.
Okay. Then you have the building and buying group, developers, purchasers.
Their training, aligning investment with strategy, choosing the right use cases, and methods for holistic risk assessment, especially spotting those unintended consequences, teaching them to actively hunt for the known unknowns, like how an efficiency-focused system might accidentally create unfairness.
And how do you make this training stick? What tools?
The sources highlight fact sheets. They're not just info dumps. Teaching teams to create genuinely interpretable fact sheets, detailing data, metrics, known limitations, potential biases, understandable by domain experts.
Not just data scientists.
Right? And training on audits. Not just running them, but how to correctly interpret the results and, crucially, figure out the specific follow-up actions needed to fix things. Making governance tangible, not theoretical.
This whole focus on competence, proactive risk management, it really shines a light on the biggest operational threat we need to tackle head-on: bias.
Absolutely. Bias is like the engine driving risk in these AI systems. So we need a really clear, rigorous definition of Chi bias or machine learning bias.
And it's not just a random error, right? It's systemic.
It's defined as AI systems producing and reproducing prejudiced results. Results that systematically reflect and perpetuate existing societal inequalities, historical biases, things embedded in our world.
And crucially, this bias doesn't just magically appear in the algorithm itself.
No, not usually. It stems from how data is collected, how it's labeled, how the algorithms are designed, how they're deployed. The sources break it down into 4 main root causes.
Okay, first one, the most common culprit: bias training data sets. The bad data problem.
Right. Data that's unrepresentative, incomplete, or just plain wrong about the reality it's supposed to reflect.
And the biggest danger with bad data: the feedback loop.
Oh, yeah. That's incredibly risky. If your AI makes a biased decision, let's say in hiring, and you then use that outcome, who got hired, to train the next version of the model.
You just amplify the original bias.
Exactly. It becomes a self-fulfilling prophecy, baking the bias in deeper and deeper. Really toxic.
Okay, cause number 2, faulty algorithmic design. This is on the developers.
Often unintentional, but yes. Weighting factors unfairly, embedding subjective rules based on their own biases, conscious or not. This is where you see correlation biases.
Mistaken correlation for causation, the classic ice cream sales and shark attacks example.
Precisely. Both go up in summer, but one doesn't cause the other. The model might miss the underlying factor warm weather and draw a faulty conclusion.
Third cause, using proxy data. This sounds subtle.
It is, and it's insidious.
Yeah.
Regulations stop you using protected attributes like race directly.
Right.
So developers use stand-ins, proxies, zip codes, maybe certain credit score elements.
As a proxy for socioeconomic status or race.
Yeah. And that can lead to unintentional discrimination, penalizing groups who score lower on that proxy, even if it's not directly related to the thing you're trying to predict.
And the fourth cause reminds us humans are still in the loop. Biased evaluation or interpretation.
Even with a technically perfect, unbiased algorithm, the human decision maker at the end can still mess things up. Their own cognitive biases, misinterpreting the output. The machine might be clean, but the human using it introduces the failure.
So if we drill down from those causes, the sources identify 6 specific types of bias that show up. This is where it gets really interesting.
First, the structural one, algorithm bias. Systematic faulty behavior, consistently unfair results, like a loan system automatically giving higher risk scores to everyone under 30, regardless of their actual finances. That's an age bias baked into the logic.
Okay, next, cognitive bias. Human thinking patterns bleeding into the design.
Yeah, like recency bias. Teams overemphasizing recent events, say the huge spike in online shopping during the pandemic, and designing a model that doesn't account for long-term normal patterns. It performs badly when things revert to the mean.
Then there's confirmation bias. We look for evidence that fits our beliefs.
Exactly. If you already believe, say, programmers who prefer Vim are more productive, you might subconsciously select data or stop collecting data once it confirms that belief, ensuring the bias gets locked in.
Fourth type, outgroup homogeneity bias.
This happens when the development team, maybe diverse in some ways, assumes everyone outside their specific group is basically the same, homogeneous, so they don't gather representative data for that outgroup. The system works great for the core demographic, but fails badly for others.
Number 5, prejudice bias, based on societal stereotypes.
Classic example. All nurses are female, all surgeons are male. If the training data reflects that historical stereotype, the AI learns it and perpetuates it, potentially filtering out qualified candidates who don't fit the stereotype.
And finally, exclusion bias, accidentally leaving groups out.
Right. Sampling improperly. Like developing a medical AI using data only from a rich urban hospital, completely excluding data from rural clinics or different demographic groups. The resulting AI might only be accurate for a very narrow slice of the population.
And these aren't just theoretical risks. The consequences are real. The business impact is huge. That recruiting discrimination case is infamous.
Yeah, the tech company trained its hiring tool on years of its own resumes. Historically, they had hired mostly men.
So the AI learned that male was a predictor of success.
Worse than that, it actively penalized resumes containing words associated with women, like filtering out someone who mentioned being captain of the women's chess club. It learned the company's past bias and automated it. Disaster.
And finance. The UC Berkeley study showing AI giving higher interest rates to minorities for the same loans.
Based on historical data reflecting societal biases, or those proxies like zip codes, clear, disparate impact.
Even dynamic pricing in ride-sharing, charging more in certain neighborhoods.
All examples of how bias undermines validity, fairness, legality, the whole foundation of trust.
So, okay, we've identified the problem in detail. How do we mitigate it? Starts with AI governance and model selection, right? That structural framework.
Exactly. Governance provides the policies, the monitoring. Then, tactically, if you're using supervised learning labeled data, you need diverse stakeholders involved in selecting and labeling that data, not just data scientists in a room.
Get HR, legal, customer experience folks in there.
Yes. People who can challenge assumptions about what good looks like in the data, what defines risk from different perspectives.
And for unsupervised learning, where the AI finds its own patterns.
The strategy shifts. These models can uncover hidden societal biases. So you must invest in and rigorously use fairness indicator tools, things like Google's What If tool, IBM's AI Fairness 360.
Tools that let the AI flag potential biases itself.
Yeah, by measuring statistical parity across different groups. It helps surface issues you might not see otherwise.
And the second big mitigation strategy loops back to people again, building inclusive teams.
Critically important. And diversity needs to be broad race, gender, Economic background, education, sure, but also diversity in roles.
Roles, you mean across the life cycle?
Exactly. You need the innovators, the sponsors defining the goal, the creators, developers building it, and the users, the people actually applying it, giving feedback. If you only have creators, they might optimize for tech elegance, but miss the real-world ethical risks for users.
And they need to watch the whole process, right? Bias isn't just in the initial data.
Correct. It can creep in during pre-processing, cleaning data, in-processing, training the model, or post-processing, interpreting results. Mitigation has to happen continuously at all stages.
And since society changes, data changes. Bias isn't static, so mitigation can't be a one-off check.
It has to be continuous, an ongoing process, which again emphasizes the need for a structured, repeatable approach, a robust framework.
Which brings us neatly to the NIST AI Risk Management Framework, the RMF.
Exactly. The NIST AI RMF provides that systematic tool. It's designed to create this positive feedback loop, balancing innovation with solid risk management. But before you even get to the framework's functions, NIST says an organization has to define what trustworthy AI actually means for them.
And they outline 7 characteristics of trustworthy AI.
Let's run through them. First, validity and reliability. Does it produce accurate, consistent results? If the data is bad or the model's flaky, you can't trust it.
Makes sense. Second, safety, sitter, height.
Poses no unacceptable danger. Life, property, environment. Critical for things like self-driving cars or medical devices.
Third, security and resilience, protecting it from attacks.
Data poisoning, model theft, denial of service attacks. It needs to be robust against malicious actors.
Fourth, explainability and interpretability. This seems crucial.
It is. Decisions need to be traceable, understandable. And the key is understandable by a domain expert, a doctor, a loan officer, not just a tech expert. If they can't grasp the why, they can't confidently act on the recommendation.
Okay. Fifth, privacy data shits, protecting sensitive info.
Using techniques like differential privacy, preventing data leakage. Sixth, fairness. Explicitly ensuring no group is favored or disadvantaged. Recognizing bias undermines both fairness and validity.
Right, they're linked. And seventh,
Accountability and transparency. The system can't be a total black box. Its function, its basis needs to be auditable, understandable. You only get real trust when you structurally address all 7 of these.
so those are the goals. How does the RMF help you achieve them? Through its 4 functions.
Right, it's a continuous cycle with 4 core functions. Function 1 is govern, steuern.
The foundation, culture, policies, rules.
Exactly. Management focus here is compliance internal policies, external regulations like privacy laws, setting the boundaries.
Function 2, map or fasten, contextualizing risk.
Defining the system's specific goal, clarifying who all the stakeholders are, and this is vital, setting the organization's specific risk tolerance for that use case.
Because tolerance varies hugely, right? Marketing AI versus medical AI.
Massively different. Mapping demands that specificity.
Function 3, measure messen, assessing the identified risks.
Using both quantitative and qualitative methods. Don't get fooled by a false sense of precision from numbers alone. This function also requires establishing TEVV processes throughout the lifecycle.
TEVV, test, evaluation, verification, validation. Can you break that down quickly?
Sure. Testing checks performance under specific conditions. Evaluation assesses overall quality and fitness for purpose. Verification asks, did we build the model right? Does the code match the design specs?
Okay.
And validation asks the big strategic question, did we build the right model? Does it actually solve the business problem ethically and effectively? TEVV brings rigor to each step.
Got it. And function 4, manage them.
Responding to the measured risks. Prioritizing risks. Choosing the response. You might mitigate it. Add controls like human review. You might accept it if it's low impact, low probability, or you might transfer indemnify it. Insurance, contracts.
And these 4 functions govern, map, measure, manage. They're adaptable?
Yes, they're abstract by design. Organizations make them concrete by developing specific profiles, tailored versions of the RMF for a specific department or a specific high-risk system. That's what makes it a practical tool, not just a document on a shelf.
This focus on trustworthiness, transparency, it naturally leads us to explainable AI, XAI, dealing with that black box problem.
Absolutely. The complexity of modern AI, especially deep learning, makes the internal logic opaque. That creates a huge trust deficit. If you, the user, can't understand why the AI decided something, how can you possibly be accountable for acting on it?
So XAI is the solution, translating that complexity into something humans can grasp.
Right. Making it understandable, traceable. XAI uses 3 main methods. First, prediction accuracy. Just measuring how often it gets things right compared to reality. Basic but important.
Second, Traceability, Rückverfolgbarkeit.
This is about the system structure. Can you follow the data from input all the way through the process to the output? Can you audit the steps, validating the inputs and the pathway,
And third, decision understanding, Entscheidungsverständnis.
providing clear, understandable explanations for why it reached a particular result, making the AI's reasoning transparent to the user, whether they're technical or a domain expert.
And the payoff for implementing XAI.
It's significant. Builds internal confidence, makes models easier to evaluate and deploy, reduces compliance risk, makes navigating regulations easier, and ultimately faster time to value because you can assess performance and demonstrate capabilities much more clearly.
But when we talk about really critical high-stakes decisions, medical diagnoses, major financial approvals, you mentioned large language models, LLMs, might not be the right tool.
Yeah, they seem incredibly powerful, and they are for certain tasks.
Yeah.
But for acting as the core decision agent in critical systems, they have two big weaknesses.
Which?
Lack of consistency is one. They're non-deterministic. Ask the same question twice, you might get slightly different answers. That's often unacceptable for auditable decisions.
Okay, and the other.
Lack of transparency. Their deep neural network structure makes tracing the exact reasoning path incredibly difficult, often impossible. So they fail those core XAI requirements for accountability in high-risk scenarios.
So if LLMs aren't suitable for the core logic of these hardened, auditable decisions, what's the alternative?
The industry standard is DMN, Decision Model and Notation. It's essentially a visual language for creating a transparent blueprint for decisions. It formally combines business rules, calls to specific platforms, even integrates ML models, all within a structured, verifiable framework.
Okay, DMN level 1 is about the visual structure.
Right. Think of it like a flowchart, but more rigorous. Use rectangles for decisions. The main decision, broken down into sub-decisions, like approve loan, might break down into check credit score, assess debt to income, verify employment, functional decomposition.
And ovals for the input data needed.
Exactly. Could be simple fields, could be complex data objects like customer application. Then solid arrows connect everything, showing the dependencies. These define the information requirements. Decision B can't happen until it gets the output from decision A.
And what about traceability back to policy?
That's where knowledge sources come in. They look like a document shape connected by a dashed line. This links a decision or rule set back to why it exists. Maybe points to Section 3.1 of the company's credit risk policy, essential for auditing and governance.
So level 1 is the map. What's DMN level 2?
Level 2 defines the actual logic inside those decision rectangles. The most common way is using decision tables.
How do those work?
Imagine a spreadsheet grid. Each row is a rule. The rows are usually OR linked if Rule 1 OR Rule 2 applies. Within a row, the conditions in the columns are usually A and D linked. EF condition X, A and D condition Y are met. The logic uses a standard called FEAL, friendly enough expression language. The key is friendly enough. It's designed so subject matter experts like risk analysts, underwriters can read, understand, and even edit the rules directly without needing to be hardcore programmers.
That's huge. It takes the core business logic out of obscure code and puts it where the business experts can validate it.
Exactly. The logic becomes an executable specification owned by the business. And this structure makes integrating machine learning really clean.
How so?
Well, a decision rectangle, say for fraud risk score, doesn't have to be defined by a decision table. Instead, its logic can simply be, call this external ML model, maybe using a standard format like PMML or ONNX, and use the score it returns.
Ah, so you combine the transparent rule-based structure of DMN with the predictive power of ML where it makes sense.
Precisely. The overall decision flow remains structured, auditable via DMN, even when parts of it leverage complex ML.
So LLMs might not execute the core decision, but they can still help build a DMN model.
Oh, definitely. They could be great supporting tools. Use an LLM to analyze huge, unstructured policy documents to suggest initial rules, or extract logic from old legacy code, or even compare versions of policies to help with change management. They accelerate creating the robust, verifiable DMN model.
Okay, this structured approach seems vital, which leads us to our final section, evaluating the output of AI, especially tricky things like language. How do you evaluate if a chatbot's response is actually good? Traditional metrics often fall short.
They really do. Metrics like BLEU or Rouge work okay for basic translation or summarization, but they miss nuance, tone, coherence, things humans notice immediately. And having humans label massive data sets is incredibly slow and expensive.
So the emerging solution is using AI to judge AI, the LLM as a judge approach.
Exactly, using a powerful, well-instructed LLM to evaluate the outputs of other models, often other LLMs. It offers scalability, and you can customize the evaluation criteria in ways that are hard for humans to apply consistently at scale. Plus, the judge LLM can often explain its judgment.
Interesting. What are the main ways this LLM judge works?
Two core methods stand out. First is direct assessment.
You give it a checklist.
Pretty much, you create a detailed rubric, a Bewertungsbogen outlining the criteria, things like clarity, relevance, tone, safety. Then you instruct the LLM judge. Rate this response on these criteria of 1 to 5 and explain your reasoning. About half the users prefer this for its clarity.
Okay. Method 2, pairwise comparison.
Right. This is often better for more subjective tasks where a direct score is hard. You show the judge LLM two outputs, A and B, and ask which one is better according to the rubric, or just which response is more helpful, natural, safe.
And you do that lots of times with different pairs.
Thousands, potentially millions of times. Then you use a ranking algorithm, often something like the ELO system from chess, to analyze all those head-to-head comparisons and generate a final leaderboard, ranking the models based on which ones consistently won the pairwise matchups. About a quarter of users prefer this method.
What are the big advantages of using an LLM as the judge?
Scalability is number one. It can just process vastly more evaluations than humans. Flexibility is another. You can easily tweak the rubric or the prompt instructions as your needs evolve.
And you mentioned nuance.
Yeah, it can assess those fuzzy subjective qualities. Does this sound human? Is the tone empathetic? That simple statistical metrics completely miss.
But wait, LLMs have their own biases. Doesn't the LLM judge introduce its own potential problem?
Absolutely. That's the catch. Like human judges, LLM judges have blind spots that can distort the results. The sources flag 3 main ones.
Okay, what are they?
First, positional bias. Positions vor Eingenommenheit. The judge might just prefer the option presented first, option A, or second, option B, regardless of quality, just an artifact of the presentation order.
Second, verbosity bias. Geschwätzigkeitsvoreingenommenheit.
The judge consistently prefers longer, more detailed outputs, even if the extra length doesn't add value or just repeats things. It mistakes length for quality.
And third, self-enhancement bias. Selbstaufwertungsvoreingenommenheit. This sounds tricky.
It is, especially if the judge model is from the same family as the models being judged. It might subconsciously favor outputs that resemble its own style or training data, even if they aren't objectively better.
So how do you guard against these judge biases?
Good evaluation frameworks have to build in checks. A key technique is the positional swap test.
You just flip A and B.
Exactly. You run the comparison, then you swap the order of A and B and run it again. If the judge changes its preference significantly just because the order flipped, you've confirmed positional bias. The framework can then use that information to try and normalize or correct the results.
Wow. Okay, this has been a really comprehensive journey. We started with that core strategic challenge, the accountability gap.
And the need for a mandated leader, someone managing not just compliance, but that lawful but awful ethical gray zone.
We really drilled into bias as the central risk, the different types, the root causes, and the need for diverse teams and governance across all processing stages.
Right. Bias isn't just code. It's data, design, interpretation. A whole system problem.
Then the NIST RMF provided that structured management framework, aiming for those 7 characteristics of trustworthiness, making it operational.
Turning abstract goals into concrete, auditable requirements through govern, map, measure, manage.
And finally, for those critical decisions, we saw the need for transparency via XAI and the power of formal design with DMN to get decisions out of the black box and make them robust and auditable.
Combining rules and ML in a structured way.
So what does this really mean for you, the listener? You've essentially got the strategic playbook now for governing AI, aiming for that integrity and continuous improvement cycle.
It's a lot to take in, but the components fit together.
Definitely. And the NIST framework describes this whole thing as a positive cycle, right? Not a one-and-done fix. So thinking about everything we've covered, closing the gap, tackling bias types, implementing NIST, using DMN, evaluating carefully, here's the final thought. What is the first single most high-impact point of governance you need to implement or strengthen in your context to kickstart that positive cycle?